All right, hi class. This is Unit 8, Lesson 4, Solving Equations and Special Cases. So, a lot of similar in today's lesson, but there are some new concepts that we'll go through. To start, let's review solving equations with one step or multiple steps. So in this first case, it is a multiple step equation. And remember, when we do our inverse operations, I'm going to want to add 2 to both sides first. So that then I have just 3x by itself equals 9. And then I want to divide both sides by 3 so that I have x equals 3. Okay. And if you want to check it, you can substitute it and plug it back in and verify that your left will be equal to just 7. Now on the right, this is more of a new concept that we learned yesterday, where we have to use the distributive property and combine like terms, and we have variables on both sides, but we're still going to end up with x equals something. So let's do that. We're going to distribute, so we have -4 times 2x is -8x, because the signs are different, so we'll have a negative answer. And then our signs will be the same. -4 times -3 will be +12 equals 2x minus 8. Again, we want our x's on one side, so I'm going to move them to the x's with more. And to be clear, I want more that are positive. So I'm going to do the inverse of a -8x, and I'm going to add 8x to both sides. So that then I have those cancel each other or simplify to 0, so that I have 12 equals 10x minus 8. Now I can add 8 to both sides, and then I see that it's 20 equals 10x. So when I divide by 10, we get x equals just 2, or we can write it as x equals 2. These are the exact same. It just, I guess, depends on your preference for which way you might want to look at it. Okay, now let's take a look at these equations. They look really similar at the beginning, so we're going to go through the same steps. I'm going to distribute first, so that I have 6 times 4x, which is 24x, minus 6 times 5, which is 30, equals 24x minus 30. And I hope at this point you already notice that the left is exactly the same as the right. They're exactly the same. So let's go through our steps. I can add a 30 or an x to either side. I'm going to add 30 to this side. And what I do to this side, I have to do that to that side. So I have 30 plus 30. Both sides will simplify. So I have 24x equals 24x. So I'm going to now go the other way, where I subtract 24x from both sides. And then these simplify to 0. And I see that I have 0 equals 0. And we'll discuss what that means when we have 0 equals 0. Now let's look at this case. So I'm going to distribute the left first, so I have 15x plus 25 equals 15x plus 3. And I'm going to go through those steps to get them on one side. First, I'm going to subtract my integer or my constant. I'm going to subtract 3 from both sides, and then we see that we have 15x plus 22 equals 15x. Now I'm going to get my x's on one side, because that's how we want to solve. We want to isolate or get our x's on the same side. So then I have minus 15x minus 15x. That is 0, so I have 22 equals 0. Well, now we have a case where something's wrong, because that's not true. 22 cannot equal 0, so this is a not true statement. I would put a cross through the equals, saying it's not equal, and we'll talk about what that means. So when you solve an equation and end up with a true statement, the solution set will be many solutions. So what does that mean? Here's an example. We're going to go through those steps to solve. So distribute. So we have 3x plus 6 equals 3x plus 6. Again, notice the left side is exactly the same as the right side. 3x plus 6 equals 3x plus 6. Then I could go through and isolate my variable, so I would subtract 6 from both sides, so that then I have 3x equals 3x. Okay, I want my variables on one side, so I would subtract 3x from both sides. And we notice we have 0 equals 0. So if we get to this point, or you notice that at this stage they're exactly the same, this is going to be a solution with many solutions, is what that means. Many solutions is what we would call this. It's a special case when solving. You plug in any value for x, and you will get the same answer out every time. Many solutions. Now let's look at this next example. When you solve an equation and end with a false statement, the solution set will be no solutions. So let's look at what that means. So when we distribute our 3 through, we get 3 times x, which is 3x, plus 3 times 2, which is 6, equals 3x plus 4. So then this time I'm going to subtract 3x from both sides. And then they simplify, so we have 6 equals 4. Again, 6 does not equal 4. That is not true. So this is where we would have the case where it's no solutions. No solution. If you have a false statement, like 6 equals 4, that's no solutions. If you have a statement like this, where it's 0 equals 0, or at this point where it's the exact same on the left and the right, that's many solutions. So those are the two differences between the special cases. Now let's practice and check what it's going to be. I'm going to first get my constants on one side. So I'm going to add 13 to both sides because it was minus 13. So then I have 6x plus 20 equals 8x. Now I'm going to subtract 6x from both sides, and we get 20 equals 2x. Divide by 2 to get x by itself, and we have 10 equals x. This is not a special case. This is what we're familiar to. It's what we've seen. We have one input for x to make the statement true, and that's what we're showing. There is also that case. That's still a possibility, and I hope that's clear. This next problem, we would start by distributing, at least I would. That's just what I noticed first. 6 times y plus 2, so 6 times y is 6y, plus 6 times 2 is 12, minus 4 equals negative 10. Then I would combine like terms. 12 minus 4 is 8. Now I would subtract 8 from both sides. 6y equals negative 18. We're solving for y, so I would divide both sides by 6. So then y equals negative 3. Again, I could have staggered my steps a little bit here and kind of shown clearly and ended up with y equals 3. It looks like on this next problem we have to distribute on the left and the right, so I'm going to distribute the left first. So it's 4 times 3x, which is 12x, minus 4 times 8, which is 32, equals 3 times 2, which is 6, plus 3 times 4x, which is 12x. I want my variables on one side because we're isolating and solving for my variables. So I'm going to subtract 12x and go this way. And look, I hope you already notice. That's 0, so we have negative 32. This is 0 equals 6. Is that a true statement? No, it is not. This problem is no solution. That's how you would write that answer. Because negative 32 does not equal 6, there is no value for x to make these expressions equal to one another. How about this one? I'm going to distribute first. So I have 4x minus 12 plus 12 equals 4x. I have some like terms. Negative 12 plus 12 is 0, so they would cancel. So I'm left with 4x equals 4x. Whoops. X. Again, I hope you notice that the left and the right are exactly the same. but we still want them on the same side, so I would subtract 4x from both sides, and I would see that I get 0 equals 0. What does that mean? That means many solutions. That's a special case. Put a box around it because that's your answer. So in the first two, we got one input to make the equality true. In the third one, we got no solutions because this is a not true statement or a false statement. And in the final one, we got 0 equals 0, in which case it's many solutions. So now I have some for you to try. Make sure to check, and if you get a special case, verify if it's no solutions or many solutions, and then if it is a regular case, show that x equals whatever number it's going to be. So, all right, thank you for watching. Let me know if you have any questions, and well, actually that's my last video, so I appreciate everybody in class, and I'll see you later. Okay, bye.